Hello everyone, welcome to our channel. Today we are going to discuss about past earthquake in India. My name is Aryan Nitin Mole, branch Civil Engineering and course Earthquake Resistance Structures. So let's start. So first we see why earthquake is occurs. Earthquakes happen when two blocks of the earth crust suddenly slip past each other along a fault, releasing store up energy in the form of seismic waves. Tectonic plates are always moving slowly, but friction at their edges can cause them to get stuck. When stress on the edges overcomes the friction, the plate slips suddenly, causing an earthquake. As shown in figure, focus is the center of earthquake, and the epicenter is a center point of earthquake at a ground level. And how waves are formed from center and travel to all directions. So this is some information about earthquake. So let's continue our presentation. So as shown in image, this is a map of India of different seismic zones by their seismic activity. There are tot- there are four zones by their different seismic activities. Zone 5, the most active seismic zone with the strongest earthquakes. Zone 4, a severe intensity zone with earthquakes of moderate intensity. Like Zone 3, a moderate intensity zone with earthquake of moderate intensity, like Zone 4. Zone 3 and Zone 4 are similar, and Zone 2, a low intensity zone. The most earthquakes happens in Zone 5 and Zone 4, which are Srinagar, Shillong, and some part of Gujarat. Here, a past history of earthquake in different location in India. We are going to cover some earthquakes from this chart, which are having more magnitude and damage the infrastructure and humans. So let's start. Kangra, Himachal Pradesh earthquake 1905 April. This earthquake happened in Kangra Valley of Himachal Pradesh, India. The magnitude of earthquakes is 7.8 on surface wave magnitude scale. Impact of earthquake killed more than 20,000 people, destroyed about 1 lakh buildings, and caused widespread damage. The earthquake was felt as far away as Delhi. Affected areas by this earthquake are Kangra, McLeodganj, and Dharmshala, as well as Jammu and Kashmir and Uttarakhand. Next is Bihar, January 19. The Bihar earthquake of 15 January 1934 was one of the most devastating seismic events in Indian history. It struck northern Bihar and part of Nepal. The magnitude of earthquake is 8 on the Richter scale. Approximately 10,700 people were killed in the disaster. The affected areas in this earthquake are Muzaffarpur, Darbhanga, Munger, and Patna. Next is a earthquake in Latur, Maharashtra, 1993, September 30. The epicenter of earthquake is Kilari village in Latur district. The magnitude of earthquake is 6.3 on Richter scale. The depth of earthquake around 10 km. The depth approximately 10,000 people, and injured 3,000 people and plus. Impact of this earthquake: thousands of homes collapsed, with over 3,000 homes destroyed, mainly in rural areas where traditional stone and mud houses were common. The cause of earthquake is relatively stable region far from major tectonic plate boundaries. Earthquake was triggered by the release of built-up stress along ancient faults within the stable Deccan Plateau. This is considered an example of interplate intraplate earthquake. Before Latur earthquake, one devastating earthquake happened in Arunachal Pradesh in 1950, August 15. The magnitude of earthquake is 8.6, one of the strongest recorded earthquake. Epicenter near in India-China border, specifically in the Mishmi Hills of Arunachal Pradesh, close to the Tibet region. In this, Assam, Arunachal Pradesh, and Tibet are affected areas. The tremors were felt across much of India and as far as Kolkata and Delhi. Deaths in this earthquake estimate range from 1,500 to 4,000, though many deaths were also reported in Tibet, which were harder to verify at the time. As we show in image, this earthquake gave huge impact on infrastructures and small villages nearly located to that area. Sumatra coastal area of Tamil Nadu, Andhra Pradesh and Kerala earthquake 2004 December 26. The magnitude of this earthquake is 9.1 to 9.3, the third largest earthquake ever recorded. Epicenter of this earthquake is the west coast of northern Sumatra, Indonesia. The depth is around 30 km below the seabed. The cause is a massive slip along the Sunda megathrust fault, where the Indian plate is subducting beneath the Burma plate, causing a sudden release of accumulated stress. In this earthquake, deaths over 230,000 people, which across the Indian Ocean region, with thousands of deaths in India, particularly in Tamil Nadu. Because of earthquake occur in the sea body, the waves traveling at high speed reached heights of 10 to 15 meters. It is 30 to 50 feet in some areas, which are very dangerous and gives huge impact on the surrounding areas of sea bodies. In India, seismic activities happen repetitively, so we need to save the structure and building to resist the seismic activities and earthquake effects. For that, different seismic retrofitting methods are applied. So, let's see seismic retrofitting techniques. Base isolation. Base isolation is a seismic retrofitting technique. Involves putting flexible bearing or pads made from layers of rubbers and lead between the building foundation and the superstructure. This base isolator moves and stretch under pressure and absorb much of an earthquake impact by reducing swaying and shaking during an earthquake, and save the building from seismic loads. As shown in figure, the building behavior in the seismic activity with only foundation, and as shown in figure B and C, when we provide a base isolation to building, they reduce the transfer of seismic load to the building structure. Also, the base isolator close-up, top plate, base plate and lid are provided with the foundation. The base isolation is used for multi-story building, like it also applied at tallest building in the world, Burj Khalifa, and other buildings in the world, to assure their integrity and structural safety while seismic activities. Another method of seismic retrofitting is provide shear wall. Shear wall is a structural member used to resist the lateral forces that is parallel to the plane of the wall, which are occurs in seismic activities. The shear wall is typically made from reinforced concrete, masonry, or wood, depending on the structure's requirement and location. Shear wall directly transfer the load to the foundation. Shear wall is along start from foundation and ends on the top floor, which act as a vertical cantilever which help the weaker portion in the building, like where beam and column join while seismic activity. The joint of beam and column is more sensitive at the time of seismic activity and chance to collapse and get deflected. By shear wall, we reduce the chances of effect on that weaker points by providing them extra supports. Here are some earthquake resistant structure design consideration. The Bureau of Indian Standards has several codes for earthquake resistant building, that including IS 1893 Part 1 2002, the Indian Standard Criteria for Earthquake Resistant Design of Structure, and also IS 4326 1993, the Indian Standard Code of Practice for Earthquake Resistant Design and Construction of Building. The third IS code is IS 13 8000, IS 13827, a code for improving the earthquake resistance of earthen buildings. These are the earthquake resistant structure design consideration. This by referring this IS code, we design the building to consider the earthquake and seismic activities. Thank you for watching a video, and please like and subscribe